Hi, today I'm going to be talking to you about the polar and rectangular form of a sine wave. When analysing AC circuits, voltages and currents typically have this sinusoidal behaviour. But how does this sine wave get this shape? Well, we can answer that by considering a unit circle of radius r, and if you could imagine, as r rotates around this circle, it actually draws out this sine wave. And this is the basis that we use to derive our polar and rectangular formulas. So for our polar, we take this radius here of magnitude r and theta, which is the angle that r makes with the real axis. So this is r, angle theta. For rectangular, we analyse this instantaneous point here and we say how far from the imaginary axis is this point, which is our x, and how far from the real axis is this point, and that's our y. So we denote that as x plus or minus yj, where j here actually denotes that this form is of a complex number. Moving on to our sine formula, we have Vm, which is our amplitude, or the maximum value of the wave. We have omega, which is denoted as 2 pi multiplied by f, where f is the frequency of the wave. We have theta, which is our phase. So if you can imagine, if you could pick up this wave and shift it left or right, this is known as the phase shift, and this is measured as an angle of how far this sine wave has been shifted from this origin here. So using this information we've gathered so far, we can use it to answer this question I have set up here. So first of all, to get our polar, we take this amplitude value and we actually divide it by the square root of 2. And we do that to obtain what's called an RMS value. And we do this because when using polar form, this r here is always assumed to be of an RMS value. And that's how we convert this amplitude to an RMS. For our angle, it's nothing more than taking this phase angle here, which is 30 degrees. Now I've already gone ahead and worked out that this is 14.1 angle 30, and that's our polar. To get our rectangular, we take this r value here, and we take the cos of this phase angle here of 30 degrees. And this gives me 12.2, which is our x value. And for our y, we take the sine of this angle, and that gives me 7.1j. And altogether it's 12.2 plus 7.1j, remembering that j denotes the complex number. And that's our polar and rectangular form. Thanks for listening, and I hope this has been insightful.